EE World, I'm Martin Rowe. We are at APEC 2024 in Long Beach, California. We're in the ST booth, and David Bates is going to tell us about delivering power to data centers. And you hear a lot about it. I spend a lot of time talking to telecom people, and this is what they're trying to do, is to get they need all this power so that they can send us videos. It's pretty much what it is. And so, David, why don't you take us through this ecosystem and tell us how this all works?
Well, thank you, Martin. So, most certainly. So, what I want to show you here is the overall pervasive ecosystem that ST offers for the data center. Starting from the power shelf of the AC-DC conversion, where the battery backup may also sit, it provides the DC-DC power to the rest of the platform, usually through a bus bar. In this situation example, we're showing a 48-volt power delivery scheme. So we have protections that help support that with our fully integrated 48-volt E-fuses. Each one of those is capable of more than a kilowatt of power. Okay.
Each one of these.
Each one of these chips.
Okay.
Each one of these chips.
They handle a kilowatt.
Yeah, and it's fully parallelable, so you can scale that out. Okay.
Okay.
From that, we're able to then to convert that power down to more usable levels at the chip level. To get there, we must convert that from 48 volts down to 12, or give or take. Whether it be unregulated conversions, such as our STC conversion, or our regulated converter, which is our stack buck converter. Both of these are highly efficient converters, greater than 98% efficiency. Okay, and from that we can bring the 12 to the main board, and we also need more protections at the main board level. So here we're showing our 12-volt E-fuse, 60 amp capable. So that's over 720 watts per chip. Each one of these ICs is, again, more than 720 watts, fully parallelable, again, to scale out.
Now, when you say E-fuse, does that mean that the fuse is essentially resettable?
It is fully resettable. It's an integrated MOSFET, and it's fully resettable with all safeties and protections involved.
Okay. So it doesn't burn out when it trips.
Does not burn out. Now the old
It opens the circuit.
That's correct.
Okay.
That's correct. Okay. From that, we then deliver the 12-volt power toward the load. How do we convert down to the load? For example, a processor may be running at, say, 1.8 volts down to 0.8 volts, give or take, depending upon the processor or the graphics chip or the AI chip. So we have multi-phase digital VR controller, which ST is showcasing here, along with our SPS. Here we are showcasing our 16-phase solution. So with a 16-phase solution, we can easily attain the most advanced processors today in excess of 500 watts, and then start targeting AI chips, which are even approaching up to kilowatts of power.
What do you mean by 16-phase? And we're not talking, AC here.
Not talking AC.
Although I have heard some people will say DC is really AC.
AC/DC. Right, here we go.
Okay.
So in this situation, when we say phase, think of analogous to a car engine where you have pistons driving, and you want more power, you can add more pistons. So it's a very similar topology. They're fully interleaved. Each one of these is a phase. You count 1, 2, 3, 4, 5, 6, 7, 8, 16.
16.
Each one is interleaved and can deliver so much amount of power or current. Okay, so by expanding that and interleaving it just like a car engine, we're able to expand the power capability and improve its performance.
So does each one, do these turn on and off to deliver power as needed?
So they can, and the controller, a digital controller, is fully programmable, and it can sense the various loads, and it says, I want to turn all the phases on, or I want to start scaling back to save power and efficiency, and boost efficiency. So the controller is the smarts of that system there.
Sure.
Yep.
Okay, and then you've got, down here, you've got going out to storage. So
out to storage. So in this example here, so again, when you have 12 volts coming into the system eventually, in this example through a regulated converter, you still need some protection. So we're showing our dual E-fuse, a 12 volt and 5 volt E-fuse packaged in one package. Okay. And that can offer them protections to other devices, such as storage devices, which ST also plays into. No, we do not manufacture the actual HDD, the hard drive, or the SSD storage device, right? But we do manufacture the chips which go into this, whether it be the motor control or the PMIC devices that power those.
Okay, very good. Thank you, David.
No problem, Martin. Thank you so much.